Hi. So this video is for the topic of greatest common factor. It will be towards the factoring test. So if you're looking to add points to your original score, this is the video for that. So I already have a video up for factoring when the A value is 1. The other one I have to put up is when the factoring and the A value is not 1. So we'll go over that as well. All right, so this is greatest common factor. You're good at it. So we'll cover 2 values, 3 values, and then we'll cover polynomials. So binomials, trinomials, multiple bases, and of course varied exponents, okay? You were good with this, so let's go ahead and dive into this. And remember, for those of you, I get so many emails of raising my grade. Read your emails, kids, parents. Read your emails. It's covered, okay? All right, so here we go. Okay, so greatest common factor, factor a number or quantity that when multiplied with another produces a given number or expression. So for instance, the product 12, right? The factors are 2 and 6, even though we know there's 3 and 4, 1 and 12, -3 and -4, right? We know there are multiple combinations. Okay, but that is one factored combination. So we're looking for factors. We want to take the number, we want to break it down to its factors, and then as far as common, what they have in common or shared, and then of course the greatest, we want to go with the biggest value, okay? All right, so here we go. Find the GCF of each. All right, so we're giving you 2 values, and then of course 2 terms, and we're gonna break them down and see what they have in common, okay? All right, so you know how to do the factor tree. You did this in middle school, right? Okay, so 42 is 6 and 7, right? Okay, you also, 6 is also 2 and 3. So these would be the primes, right? 42 is created, so this would be the prime factorization. The prime factorization of the number 42 is 2, 3, and 7. Okay, now 45. As far as a number 45, you get 5 and 9. And then, of course, 9 can be broken to 3 and 3. So the prime factorization for 45 is, whoops, I have to look through my phone, 3, 3, 5. Okay. All right. We want the greatest common factor for 42 and 45. So what is the largest number I can pull out of here? What do you think? Just 3, right? Okay, so it would just be 3. Now, 3 goes into 42, right? 3 times, what was that for? 14? Oh my gosh, no. Oh my goodness, yeah, it was 14. Okay, whoops. 3 times, where's my calculator? Oh, here. But one of the kids took it. Oops. Okay, so 42, whoops. 3 times 14 is 42. Right, I had the window open, so I got all dusty. Okay, so 3 times 14 gives me 42. And now what's 3 times, right? 3 times 15, oh, you can't see. 3 times 15, it gives me 45. Okay, so our GCF is 3 because that is all, that is the factor, 3 and 3, that is a factor that is shared, right? Because common, and that's the largest number that I can pull out. Because look, 2 times 3 is 6. I can't produce a 6 here. 3 times 7 is 21. I can't get that. 2 times 7 is 14. I can't produce that other value with these prime factors. Okay. All right, here we go. 32 and 21. All right, let's break up 32 and 21. So this is 4 times 8. I don't think we can really do anything else because 21 is 3 and 7. There's no way I'm going to get a 3 and a 7 out of these values. This is 2 and 2. This is 2 and 4. This is 2 and 2, right? If I break it up into prime factorization, 2 times 2 times 2 times 2 times 2 gives me 32. 3 times 7 gives me 21. There are no shared factors. There are no shared factors that you see in this factor tree. However, that is not what you would write, even though it would be very, very common, because if you don't see it, what is the number that all products have in common as far as a factor? Our very special number 1, right? Because 2 is 1 times 2, 7 is 1 times 7, and so there is your greatest shared factor. So I know sometimes you might want to say there are no shared factors. No, don't write that. You'll get it marked wrong. It's the value 1. Okay? It's not 0 because anything times 0 is 0, so don't go with 0. Okay. Let's go to not just values, but now we have multiple bases and varied exponents. Okay, let's do the 44 and the 16 first, and then we'll get to the variables, to the bases. Okay. All right, so 44 is 4 and 11. 16 is 4 and 4. Okay, now I could have made this 16 and 1, but 16 does not divide into 44, right? Because 6, whoops, that's blocking. 44 divided by 16 gives me a fraction, so it's a no-go, okay? So I knew to take it to the 4, and so my greatest common factor is 4, correct? All right, so now we have to address our bases. Okay, so 4 is taken out, and I'm going to build from here. Okay, why? Remember, if you do not see the exponent, it is always implied it is a positive 1. So if you don't see it, it's there, it's a positive 1. All right, so now look at your y's. I have 1y here, just 1, right? And here I have y squared. Y squared means there are 2 y's, y1, y1, right? Because what's 1 plus 1? 2. So how many shared y's do they have? And smallest wins here. So it's 1y. So now I'm going to pull out 1y. And whether you write the 1 there or not, it's up to you. But just know in mathematical textbooks, Khan Academy, worksheets, the 1 isn't written, okay? All right, now let's look at our x squared. All right, I have x squared, and that means there are 2 x's, right? 1 plus 1 gives me 2. I have 2 x's. 1 plus 1 is 2, right? So I have 2 x's. Okay, so how many x's are shared? And in this case, it's both of them. They both have the exact same number of x's, and so my factor is x squared. And so my GCF is 4yx squared. So you're trying to identify what they have in common. Okay, so now let's do 3 terms, a trinomial. 35uv, 50v, 5u. Let's look at the coefficients first. Let's look at the 35, the 50, and the 5. All right, if I break it down, this is 5 times 7. 50 is 5 times 10. It almost looks like a 54, right? But it's a 5u. This is 5 times 1. All right, what is the shared factor? The greatest shared factor? It is 5. They each have a factor of 5. I'm trying to put the, okay, you can't see, but I was trying to put the top on there. Highlighter wasn't working, kept moving away. All right, now let's attack the letter U, the base U. This has one U, this has no U's, and this has one U. Okay, I wrote up above, so now where do I write? Let's come over here. Okay, I have one U on the first one. I have no U's for the second one. And for the third one, I have one U. I have none here. No U's, none. You cannot take out what it doesn't have. And so because none, 0, it can't share something you do not have. And so that always wins out. So here I cannot remove a U because I have 1, 0, 1, 0 wins. So I cannot remove a U. Okay, so now let's look at the V's. There's one V, no V. So I have one V, no V's. None wins. So I cannot take out a V. And so my greatest common factor is just 5. That's it. Okay, I'm going to stop this video and then I'm going to move on to the finding the common factor now with multiple terms, where now we have our grouping symbol, the parentheses, which we're going to move into factoring where the A value is not 1. And so that's why we're doing this first. Okay, so let me stop it and then I'll start up the other one.